Okay, so hello, welcome to week 4. Um, you know, it's kind of the same as last week's. But today we're gonna be learning some more stuff. Um, Today we're gonna be designing with canvases, and we're gonna be kind of dabbling in some assemblies. So, oftentimes you might want to be designing something, that you might want to reference like something that you have in real life already. So let's say, like for example, like you have a barbecue and there's like a knob on it, and then the knob breaks off, and you want to make a new one. Um, like you can like measure it and stuff like that, which is awesome. But what another thing you could do is you could take a picture and you can use it as kind of a template for whatever you're making, right? So you can use the photo and then you can measure it and then make your model off of that photo, right? So what we're going to be doing today is we're going to be reverse engineering the engineering fountain here at Purdue. So here's this lovely photo of the engineering fountain. The photo I have for you is slightly different, but we're going to model like our own version of this. Obviously, this is going to be super rough, so it's not going to be exact, but it'll kind of give you an idea of how this tool could be useful. And a lot of people would use the canvas tool when like modeling cars and stuff like that. So they get like a front shot, like a side shot, top, bottom, and like back shot. And then yeah, very funny. But then they can use that to kind of scope the profile of the car and then create the model. So um, we're not going to be doing anything that crazy. We're just going to do the engineering fountain, but it'll give you a taste of the tool. So I should have posted it already. If you go under resources, there's this image of the engineering fountain. It's a nice like straight shot. So you can download this and then we're gonna upload it to Fusion if I launch it. Also, is anyone missing a mouse today? Slash need a mouse? Okay. Please give it back. I don't want to lose it. Yeah, computer being slow. Okay, here we go. So to import this image, obviously you have to download it first. But then there's this canvas photo on the top right. And again, if you hover over it, you can kind of see like how this is used. This person had like a concept drawing for their car and they modeled it after that. Again, I'm just going to click this. I'm going to import a document. So here's the engineering fountain. And then you want to select a plane. Obviously, it's like a 2D image, so you want to put it somewhere in your 3D space. So I'm just going to click on this one here. And then you can like resize it and stuff like that. So here's a bunch of options if you want to move it around. There's also like the canvas opacity. Wait, I'm going to make this wider so you can read everything. So yeah, if you change the slider, it'll become like more or less translucent, which might be useful. I'm just going to leave it at 50, but yeah, there's a lot of these different options for you to choose from, but I'm not really going to do anything. So I'm just going to press OK. You can see here, like the model is just, or the image is just in space. But now that we have that, we're going to start modeling the engineering fountain. And similar to last week, we're going to be modeling like a portion of it, and then we're going to be patterning it. So we are only going to have to model one side of it instead of modeling all four, if that makes sense. So like for the gears, we like circular pattern the teeth. This is going to show you that you can pattern bodies as well. So I'm going to create a sketch. I'm going to make sure it's on the same plane as the image I chose, or in the same plane that I placed the image in. And then I'm going to start drawing. So I'm going to pick one corner. I typically just go for the right side, and then I start tracing it out. So I'm gonna make a couple straight lines here, and then I'm gonna make this curve. A fun fact about this curve is that I've been told that this curve is actually not a circle. It's modeled after the e to the x function. So if you tried to create like a circle and overlap it with the area, it's not going to fit. So we're going to estimate it with something called a fit point spline, but I'll get to that once I create these vertical lines here. So for this model, you don't have to worry about it being fully defined. It's just going to be like kind of eyeballed. So I'm going to go like horizontal here, and then I'm going to go to the bottom. One of the things I like to do is because we're splitting these two like sections, I like creating like a little point on the bottom that I can like trim all the entities to. So I'm going to create one point there, like another one here, and then I'm going to go across some more, and then I'm going to go up. Again, it doesn't have to be exact. Don't worry about it too much. But I'm going to hide the canvas just so you can see where I'm at. I made like this top line and then these horizontal lines. Again, these are broken up into a couple pieces. It'll just make it easier to cut later. But yeah. The next part, I'm going to use that fit point spline. So I'm going to click on the top. And then I'm just going to click a couple points along the line or along the curve of the engineering fountain. I'm going to make sure that I'm going to make one of the points right here and one of the points there, just so when I trim it later, it'll be a little bit easier. Okay, so I'm going to follow it to the bottom point, and then I'm going to hit that check mark. And then you see, if I hide the canvas with the little eyeball, you have this nice smooth curve. I'm going to split it up into two pieces because it's like one solid part right now. So using those 2 points that I made earlier, I'm going to create a line going down. And then I'll create another one. So you see here, this is kind of roughly an engineering fountain. Maybe I'll just make this vertical because I want to make this vertical too. Okay. Raise your hand if you're not here yet. If you want to hide the canvas, there's this little eyeball in the top left corner. Yeah. I'm gonna just trim away the excess. Some of you have already done it, but I'm gonna trim these lines away to make two separate bodies. These green like circles and lines, it's totally okay if it's just kind of going all over the place. These are just kind of there for the splines, and if you manipulate them, you can like change the curve like this. But obviously you don't want that, so I'm just gonna leave it how it is. I'm gonna finish it, and then I'm purposely gonna do this wrong just so you see like what it's gonna be like if you do it wrong, and then I'll fix it later. So I'm gonna start by extruding it. You're gonna want to extrude this in a symmetric manner, but I'm gonna do it one-sided just so you see what happens. Um, Maybe that was too thin. Okay, so you should have this. Raise your hand if you're not here yet. It's okay. All right, I'll chill for a second. Okay, so now that we have this, I'm gonna pattern it. So obviously I did it purposely wrong so you'll see what happens. But similar to like what we did for the gear last week, you're gonna create a pattern and do a circular pattern. you're going to select the two objects here, and then you'll select an axis. So in this case, like I want it around this green line right here. But if I set it to 4, which is the amount on the engineering fountain, you'll see that like these are not really centered properly and it looks kind of weird, right? So if you experience this, it's probably because of how you extruded it. You can see, I don't know how well, oh, you can see it. You can see this blue line here, which is kind of like the plane at which we extruded it from. And you can see, because the extrude wasn't symmetric, it makes this weird pattern, right? So to fix that, you're going to want to edit the feature and then change the direction to symmetric. And then I think you have to divide the distance in half to make it the same width. But when we do that, you can see now this looks a lot more like the engineering fountain, right? Does that make sense? Again, I was doing it wrong on purpose just so you can see how the way you extrude things can affect your model. So yeah, does that make sense? All right, cool. Okay. So the next thing is we're gonna add like these little details on into the engineering fountain. If you look closely, it has like this fun like cutout section. What we're gonna do is we're gonna kind of trace something, or you can do whatever you want. I had someone do like a smiley face, which is fine. But we're gonna cut it into the model, and then we're gonna mirror it, and then we're gonna make sure it applies to all the different bodies that we created. So again, I'm purposely doing this out of order, just so you know, just so you can see how you can manipulate like the models and stuff like that. So if you don't want to roll back the circular pattern, you want to make sure you model this on the original body. Again, remember how I was talking about like dependencies last week with like the fillet and stuff? If you model something onto one of the pattern things and you try to like roll things back or move it, it's not going to work because you created like a dependency. So please model on this original one. If you're trying to figure out which one it is, you can click on your extrude and then it'll highlight it in blue. So you'll know this is like the original one and then the other ones are the copies. So now that I know, I'm going to create a sketch on one of them right here. I'm going to show the canvas again, and then I'm going to start tracing like these features here. So again, it doesn't have to be perfect, but we can use the image to help us. The other thing I'm going to do is I'm going to project some of these lines because I want like these sides to be like referenced, so it's a nice like clean cutoff. So I'm going to press P, and then I'm going to select like all these vertical lines and these horizontal lines here. So I'm going to do that real quick. Oh, oops. So when I do that, I have these nice purple lines, and then I can create some of my details. So I'm going to use the fit point spline. You're free to use whatever tool you like. And I'm going to do these fun like curvy bits.
How did you project it?
You press P and then you click on the lines that you want to project and then you press OK. Yeah. Okay. So if I hide the canvas and even the bodies, you can see here, like I have these two like closed features. And it's because, you know, I was referencing these purple lines and we can use them for our cuts. At least I'm pretty sure we can. Again, these are all arbitrary, so don't worry if it's blue. But I'm gonna extruded cut. You can see here, I can select these because they're closed. So I'm gonna select these two. For the distance, I'm gonna do like 0.1, I think. It's going the wrong way, so I'm gonna set it to negative, maybe a bit more. But when I do that, I press OK. There's this nice cut here. Any pattern you want. Maybe make it school appropriate though. Hence, we're in school. Okay. Does anyone need more time on this?
Oh yeah, no, I usually, this is a habit I have in Rex. I always select the axis because one time one of my faces just slightly off, and I create a sketch of not align the axis. So what I usually do is I just create it from the axis itself, so I know it's far. No, he's gonna say.
Now that we have,
Should I be cutting into it or?
yeah, you should be cutting.
Okay.
So now that we have one detail here, I'm gonna make sure that I create a symmetric detail on the other side. So there's a couple ways you could go about doing it, right? You could use the mirror function, like the create mirror, and then choose the extrusion, and then mirror along like the center plane, if that makes sense. You could also create another extrusion referencing like this side instead. I'll just do both so you can kind of see like the differences. There's very minute differences between these two, and there's some cases where you might favor one over the other. In this case, I would probably go for a mirror because I want them to be symmetric all the time. But if you wanted one to like sometimes, like if you wanted to be able to change both of them, then you might want to do like a double extrude. So I'll just do the double extrude first. So I'm going to show the sketch, and then I'm going to create an extrude. I'm going to select the same profiles, and then for the start, instead of the profile plane, I would select object, and then I would select the other side, right? And then you can manipulate like, oh, oops, not the offset. You can manipulate the cut, and then you get this result, right? Obviously, like because they're independent of each other, you can change this to be like more than the other. So like you see now like one is cut deeper than the other, right? So this might be like if this is the geometry you're shooting for, this is one way you might want to do it. But for me, like I want this to be symmetric, so I'm gonna just mirror this feature across the plane. So this is another advantage for like a symmetric extrude because you automatically have a plane like in the middle of your model. So it can be really useful for stuff like this. So sometimes when I'm just like modeling stuff and then I want to put holes in it, I'll just do like a symmetric extrusion just so I have like a plane in the middle and it's nice. That's just personal preference though. But yeah, so I'm going to create a mirror. Instead of bodies for the object type, you can change it to features. So I'm going to select the extrusion, and then you can select the plane. In this case, you want like this plane here, right? Because it cuts through the center of the model. You can see it kind of gives you a preview, and then when you press OK, it creates that mirror, right? Again, if I was to change this side, now that it's mirrored, it changes both of them at the same time, right? So again, two different ways to do it, two slightly different results depending on what you're doing. But yeah. So if you've been doing it the way I've been doing it, you can see that the detail's only on one of them and not on all four of them. And it's because we've been editing that original one. But again, because like CAD can like regenerate things if you organize your timeline, you can like make them all symmetric if you're doing this right? Because we edited the original one, this circular pattern isn't dependent on all of these features we've made. So what you should be able to do is you should be able to drag this across, and when you let go, it'll apply the same feature to all of them. Does that make sense? Again, I'm purposely doing this out of order just so you can see that you can reorganize stuff, and it's pretty cool. But yeah, did anyone have trouble with this? If you modeled it on the wrong body, then you might have to redo it. But yeah. All right. Cool. So the last thing on this is just making a circle with a hole in it. Nothing too crazy. I'm just gonna do that real quick and create a sketch. I'm gonna click on this bottom face, and then I'm gonna make a circle off of the origin. And then I'm just gonna extrude it. Oh, I forgot the hole. Let me fix that. There we go. All right, I'm gonna walk around for a bit, make sure everyone got that.
How do I move this? Because I want to do this. But I need to find a sketch.
Okay. Does anyone have questions about the engineering fountain? All right, cool. So this is a little bit different from what we've been doing. We've been doing a lot of sketching and modeling. But typically when you model stuff, you're not really making just one thing. You might be making a group of things that work together, right? So we'll typically call these things assemblies. And the nice thing about CAD is that you can virtually build your assemblies before you actually make them. This is a really good thing to do because um, you can kind of catch things early on if you look at a model. Uh, and also something to think about when you're making these assemblies is you should probably be thinking about how you're actually going to put them together in real life. Because people have like sent me assemblies before. Not in this class, but in like clubs and stuff. They'll send me an assembly and I'll like go to make it. But then it's impossible to build because like to make the part go where it needs to go, it would have to like phase through the other part, right? So that's one limitation that you might want to think about when creating these assemblies, because you can literally do whatever you want. Things can like overlap each other, they can phase through things, but obviously you can't do that in real life unless you like break the laws of physics or something. So keep that in mind when you create these assemblies, when you're building more complex things that you want to make, because if you can't put it together, then you're just going to be sad and you're just going to have a pile of parts. So you don't really want that. Thankfully, like we're just going to be doing Legos today, so they should fit together pretty easily. Um, you know, I'm sure most, if not all of you, have used these kinds of bricks, so it'll be interesting to build them on the computer. Obviously, it'll be a little bit more tedious just because you're not used to it. But this is a good exercise to get you used to making large assemblies. So yeah, if you ever like go and work for a company and open some of their assemblies, sometimes your computer will like blow up because it has like thousands and thousands of components, sometimes like millions. So this is very like simple, but like these assemblies scale all the way to like airplanes and stuff like that. So that's how they like build them. So yeah, basically we're just gonna do a nice and simple one. So you just want to download this zip file. I swear it's not a zip bomb, so don't worry. Um, I'm gonna create like a folder just to organize things a little bit better. So I'm gonna upload it, find the files. Obviously, you're gonna want to unzip the folder when you download it. But then you're gonna copy all the files into Fusion. Bless you. Okay. I mean, if you have a problem accessing these files,
Yeah, why don't we use line and like move to point instead of joint? Sometimes because
that's kind of how I was taught to teach these the joint tools have gotten a lot better.
yeah.
I've never actually used the align tool, but the nice thing about the joint stuff is that it unlocks like animation. Yeah, like and also just like all the different types. There's like a revolving joint or like a fixed joint, right?
It affects. I think, to be fair, this is not what you should do for every engineering project. I deleted the timeline because it made my laptop twice as slow. So I just deleted because I was like, we're engineers.
No, no,
If I
no.
have the design, we can figure it out how to put it together.
What you do is
There were certain points in the robot that were like really hard to put together because like it would be really hard to sneak in the screws in. But the point is, I use align a lot more because joint and and timeline's kind of goofy, and going without timeline's kind of goofy.
Yeah.
So
What you could do is get.
I did
But that is a nice
no, it's
idea.
cloud. It's cloud.
Well, it's a lot of the stuff local.
I've done that. I kind of supposed to. It's like I just had to sacrifice some time because it just made my laptop twice as fast. I was like, who's ever gonna need to learn how to put it
My
together?
first CAD computer had an Intel i5 and like 8 gigabytes.
Yeah.
Was that for like high stakes?
Huh?
High stakes.
Yeah, that was for high stakes, bro. Turns out my school didn't even have the parts for the I made 4 designs for nothing.
No.
I made 4 designs for nothing.
That's tragic. Okay. Does everyone have these files? Yeah. Okay.
That's a great question. For chance to be uploaded. I mean, it didn't, maybe it didn't like log in. We'll look at the everything. Big question. Even is it a problem? Fair enough. Yep. Seconds are like the one thing that I haven't learned. $50 right? It's always super fast. It's always. Yeah, I'm sure you'll see that a lot of the rest of the rest everything to make it so we usually operate like an actual folder. So when you get into the file, it's extract.
Now that everyone hopefully has all the files, we're gonna start creating an assembly. So the first thing you want to do is create a new document. So just open a new design. Okay, I have no idea what is going on right now. All right, everyone, calm down. Okay, thanks. Wait, I'm going over. Okay, so you need to create a new document. But the first thing you need to do is you need to save the document. So it's just gonna be blank, but you just want to save it and then call it, Lego car assembly or whatever you want to call it. And then you can start inserting components. So, typically when I create an assembly, I want to start with like the quote unquote like foundation of the part. So I don't want to just choose like the steering wheel or something because like that part isn't really like I wouldn't say that's like the foundation of this car, right? I would say like you would probably want to start with like a frame piece. So I typically start with like the 2x6 like plate that runs across the whole car. Because for the first component, Fusion will ground the component to make sure like that part doesn't move. Because if everything is unground and you start like adding joints, then things are just gonna like start flying everywhere, and then it'll be really hectic. So you just want to start by adding like your foundation piece. So you can just drag and drop, or I think you can right click and do like insert into design. It just kind of places it like arbitrarily, but once you confirm it, it'll be grounded. So I think this is fine. I'm gonna press OK. If you look in the top left, you can see this little anchor. So the anchor is just showing you that it's grounded. So it's kind of like the fixed constraint, but for like components. It put mine in like at a 90-degree angle. Uh-huh. Is there a way to fix that? So when you insert the component, you can kind of like rotate it a little bit. I can do it again. Yeah, you got it? Okay, cool. But yeah, so we have this piece. Obviously, we need to add more pieces to make an assembly. So I'm gonna start by adding like these axle pieces that go in the front and the back. You can see when I insert it into the assembly, it's like phasing through the part, right? So again, CAD doesn't really like recognize collisions, so you have to keep that in mind when you're assembling things. One of the things I like to do is I might like move the part to be close to where it's going to be, but I don't want to make it exact, right? Because like whenever you create a joint and like join two parts together, it'll make a little like animation of the parts flying in. And if the parts are too close, you're not really gonna notice what happens. So if it's wrong, then you won't know. But if the parts are far enough away and they fly in and then the part looks really weird, then you'll kind of know. So for this, like I'm gonna make sure like there's a small like air gap in between these two parts when I place it. I'm gonna confirm it and then I'm gonna start joining it. So if you've used other CAD programs, the joint tool in Fusion is a little bit different compared to maybe like SolidWorks or Inventor. Some people have their preferences towards other assembly types, but this is just how Fusion does it. So it might take a little bit of getting used to if you come from another CAD program, but it's not super bad. It used to be a lot worse, but they actually made it better. So yeah. Where's the assembly? Okay, 1 second. Am I blind?
Next to modify. Right.
Oh yeah. Okay, sorry. I'm like I haven't done this in a bit. Oh really? Okay. Well, I typically just press J, but I forgot where it was in the toolbar. But if you go in under assemble and joint, you can open the joint tool. I usually just press J, which is why I forgot where it was. But this little open window will open up on the side. Personally, for like big like angular things, I like using like the two edge intersection because I find it to be a little bit more precise sometimes. So I'm gonna do both of those. But basically, like for edge 1 and edge 2, you want to assign like two edges that are corresponding with each other. Yeah, I'm saying edge. This is so funny. Okay. But yeah, so I'm gonna like pick these two corners that are like perpendicular to each other, and then I'm gonna pick the corresponding ones here. So right here and there. Oh wait, come on. And then there and there. And then you can see like the part flies into itself, right? Or into the other spot. Um, it's actually interesting because like the grounded part flew into the part that was ungrounded, but that's okay because once you confirm the joint, it'll apply all those grounds and other constraints. So I think it normally applies, it flies like the first part that you select to the second part. So that's why it does that. But when you confirm it, you'll see it'll snap back into place. But yeah, I'm going to be doing it a couple more times. So if you didn't get it, don't worry. I'm going to do this wheel piece again. So I'm going to move it around. I'm going to create a joint. I'm going to press a J. I'm going to do the two edge intersection. So edge 1 is this one, edge 2 is there, and then the two corresponding edges there. It'll fly in. You can see like it kind of like breaks the other one, but then once I confirm it, then it fixes itself. So no need to worry. But yeah, does anyone have any questions about this?
For some reason, when I tried doing it like the axle, so that it was like the axle, I took like the axle and then the other hand, I mean the two balances.
Yeah.
It'll like not work. I can't like do it.
Are you doing the two edge intersection?
The two edge intersection.
Yeah. So when you create a joint, there's like the simple one, but then there's this other option for two edge. And that's the one that I typically use.
Oh, I was not using that. I was
Yeah.
simple.
Simple is good for, I like to use simple for round stuff. So I'll be doing that in a second for like the tire. Okay. Okay. So now that you might have a taste for these joints, I will say you can have assemblies inside assemblies, right? So that's what we typically call sub assemblies. So we will have like a main assembly. In this case, it's like the main Lego car. But like if we look at this model, right, there's 4 sets of wheels and tires, right? But we don't want to create joints for every single wheel and tire. So what we can do is we can create its own separate assembly with just a wheel and tire. We can join that, and then we can import the sub-assembly into the main one. So that'll save you a little bit of time. So I'm going to do that now. I'm going to create a new design, and then I'm going to insert, oh wait, I need to save first. I'm going to insert the wheel. It's grounded, and then I'm going to insert the tire. So again, you can kind of see how like it's basically where we want it to be, but there's no joint, right? So I'm going to purposely move it farther away. So when I create the joint, I can confirm that I'm placing it in the spot where I want it to be. So I'm going to select J. In this case, I'm going to use a simple constraint because it's just like one edge corresponding to another edge. So I'm going to click this one and then this one here. And then I'm going to press OK. Obviously, I'm going to have to save the file again, or else it'll just be blank when I try to insert it into the sub-assembly. So I'm going to save it. And then when I go back to the main assembly, you can see in the data panel that there's a new file called wheel subassem that I just created. So I can insert that, and now it'll insert both of them into the design. So that saves a little bit of time. One important thing to note about these simple constraints, especially with these axles have a lot of different features on them, especially like the inside of this piece. So when you select a joint, you might select it wrong. So I'm going to just show you what you might want to pay attention to not make a really weird joint. So I'll do it wrong first so you can see what it might look like, and then I'll do it right. So for this, again, I'm going to be using the simple joint just because I'm doing like 2 round things. I'm going to select this edge right here. You can see how like if you're looking carefully, there's like a little like origin where my mouse is, but once it like hovers towards like certain objects, it'll snap. So like it'll snap to like the center of this axle, and you can see how the origin moves away from my mouse, right? In this case, this is what we want because we want like it all to be in relation to the center of the axle instead of like this point right here, right? So I'm going to select this, but I'll show you what happens if you select it like incorrectly, because this part can be a little tricky if you're not paying attention. You can see like as I run my mouse over, there's a bunch of like little points along like the edge of this kind of like plus size or plus shaped like axle piece. If you move your mouse towards any of them, it'll snap to that instead of the center, right? So if I did it incorrectly and I accidentally snapped to this point instead of the center, you can see how like the axle isn't in the right spot, right? And it's funny because like when you change the motion to like revolute, it'll like make it super weird, right? So if I confirm it and I like try to move the tire, you can see it's like all lopsided, right? Which is definitely not ideal. But if we do it right, and to create a joint, I'm going to select the center here, and then I'm going to select the center on here. I'm going to make sure, a lot of the times it's sometimes helpful to like zoom in really close to see where this origin is going. You can see how when I run along kind of like the middle of this arc, or I guess the quarter of this arc, it'll snap to the center. But if I go farther, it'll snap to like the midpoint of the arc or the edge of the arc. So if I'm somewhere in the middle, it'll snap to the center, which is what we're looking for. So when I do that, you can see this is rotating in the right spot. Oh, also, yeah, I forgot to mention the motion part. So for all the other pieces that like don't really move together, you typically want to set it as rigid because they're not going to move in relation to each other. But you can see there's a bunch of different options for you to choose from. In this case, because we want this wheel to be able to spin, we can set it to like this revolute motion type. You can specify the axis. It usually auto selects pretty good. And then if you preview it, you can see, well, because of the order I selected it, the axle is spinning and the wheel's not. But, the wheel can spin in relation to the axle. So when I confirm it, you can see like the axle's not spinning, but the wheel does. So that's good. Any questions? I'll let everyone do this for a little while. The last thing about this is you want to make sure you add appearances to your Lego car. So again, if you're adding appearances, please don't make it gray because then I'll just assume that you didn't add an appearance. So yeah, the more colorful, the better. It'll be really obvious to me or whoever's creating this. Why can't I see the video? Did you save it?
Use, okay, so go back to your wheel assembly.
I would recommend you just save all the files.
So like all the regular ones in there, or just do everything.
So
He didn't say that it was.
what I did is I
So you
just
say
put
red,
all of them.
that's
Like
right.
I made a project called like fall 2020.
Okay, and then everything should.
I put sure stuff
Cool.
in it.
Okay.
And then I made a folder inside for the Lego color stuff.
So I probably just been putting that all on my project. Yeah.
Oh, okay, yeah. He did Lego. Is it there?
Yeah, he did Revolut. Yeah. Okay. So it's in my. He put Revolut for the okay. She did save, but the wheel's not showing that. The wheel's not showing on.
Let's see. Oh, wait.
It is, but she did, insert into, she did insert in, just, it populated something, just a blank, coordinate. It says something. Because it wasn't there before, so you can't.
I read the rubric, it says only have 20%.
The real challenge is to find strictly by different. Which is hard. No one like that.
This is already
Alright, so do we have to download that?
yes. So there's a bunch of like stuff.
Yeah. It just went back to the first one, so we put the first one in this one. The survey reference like very consistent. I did most of this with just the simple one. There should be, you want to select the center of that? And select it to the center of that. Oh. Select the center. You want to zoom like so zoom in really close to the. For one specific part, say, I don't know. I don't know if it was a specific part. No, 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 from the edges. Kind of a V1. Move that, so turn around to the top.
Because you have like buttons.
So, you might be able to. So be careful. Move over the one. It's real. It's real. Like, center? Yeah. Yeah, I see. That is. I don't know, this is a weird, unique. Like mine's here. So, you're gonna want simple, so make sure you
Yeah. Um,
make sure you can.
Here, I'll show you. Okay, so you see, I'm gonna I'm gonna use this edge right here, and then I'm gonna mate it or join it to like this one. So, well, yeah, that's why you have to be really careful because it'll sometimes snap. Like you can see it snapping to the midpoint of the arc. But if I move my mouse over here, it snaps to the center of the circle. Yeah. So you need to pay attention to where the little origin is.
Yeah, sort of that word. Sometimes it's not snapping. So it controls. So you see how we're going to use that like a little margin thing? So if I just click here on it, it's gonna be right there. That's what the notification is. So we.
The rubric, it says use at least 25 breaks. So can I use the break in here?
See? You have to make the same page, but the program
I just submit the same part, but stack is like 25 times.
same deal.
Understand? Let's go.
That one's nicer. Like, you got the motion. And then we have the motion.
I just need to do it once and I just copy paste it.
And,
It's gonna be such a big one.
yep, of course.
The 2x6. It's 25 bricks, not 25 different bricks. It says 25 bricks now? Yeah. No. Rubric.
Technically, you can use 25 the same way. I encourage you to not do that. I'm not going to stop you from doing it. Yeah, that's fine. Okay, I'm going to talk about the homework real quick, so you might want to listen up.
You said no, right? They make it all one other color, is that why?
Yeah, that's fine. Okay, I'm gonna talk about the homework real quick, so you might want to listen to this or don't listen to me. Um, okay, so your homework for this week is very similar to what you've just been doing, but a little bit more. So, your homework for this week is to create an assembly with 5 different Lego bricks. I'm not saying they have to be 5 unique Lego bricks. So if you really want to stack 25 of the same thing, I'm not going to stop you. Some people have already started doing that, and you can do that. I encourage you to be creative and try something new. But if you don't want to, then I can't stop you. Um, One of the things I encourage you to look at, even if you don't use any of these bricks, is to look at online repositories. So I'm going to show you a couple, and I'm going to send a couple links later. But this is like kind of an important part of like design that some people don't talk about. Um, because a lot of the times you're going to be using things that already exist and you don't want to spend the time to model it, right? So, for example, like a lot of people like to design things that use skateboard bearings because they're really cheap and they work pretty well for like a lot of applications. So, you know, the skateboard bearing already exists, right? It's not like no one has CADed a skateboard bearing before. So what you can do is you can go on online repositories to find them. So one of my repositories of choice is called GrabCAD, um, but there's a bunch out there, right? So, oops, wrong website. GrabCAD library. So you can see here, like these are things that people have modeled already and posted on here for free. And you can use these models to like make stuff, right? Like this person did like this Audi bumper for or like a bumper for his car. But people do like a bunch of crazy stuff like radial engines and all that fun stuff. But you can also find like, very typical stuff that you might want to use, like a skateboard bearing. So if you didn't know, a skateboard bearing is like the official like engineering term is a 608 bearing. Um, so if you look up, oh, maybe bearing. If you look up 608 bearing, you'll see that like people have already modeled like ball bearings for you to use, and you can download them and insert them into your designs. Obviously, we're doing Legos, so we don't need like a skateboard bearing, right? But if you looked up Lego brick, there's stuff out here too, right? And this is just one website. I'll send some more. But these can be pretty useful when you're designing things with like standardized hardware. Um, Again, this is kind of unrelated to the homework, but like one of the other repositories that you can use is something called McMaster Car. So if anyone has experience with McMaster, this is like the best online hardware store that ever existed. You can buy everything from like screws to like, um, you can buy candy on here, which is funny. You can buy like hot chocolate, and you can also buy speed limit signs. But do with that information with whatever you want. I'm not gonna tell you to do anything. Anyways, you can use McMaster whenever you're designing stuff with hardware, to download like hardware, right? So you can download nuts and bolts off of here. Um, so like, let's say I wanted socket head cap screw. There's all these sizes of all different lengths. You can get them, like you can download them with or without threads to make your like if you want to make your computer blow up, you can have it model threads for you if you really want. Um, but yeah, you typically just click on the part number and you can see here, like there's a bunch of CAD options. Typically, like I would recommend you use a step file. You can see there's like one that has threads and one with no threads. So if you're using a bolt, maybe go no threads so your computer doesn't throttle. But yeah, it's available in a bunch of different formats. You can even get like the 2D part drawings as well. So this is a pretty nice resource to have whenever you're modeling stuff. But yeah, I'll send some more links later, but know that these resources are available to you when you're designing stuff because it's super useful. Um, I I think I placed for the steering wheel, I placed um the the 2x1 in front, and then I constrained the steering wheel base to that one. I can do it real quick.
Can I use a line for that one? Because like it's slightly angled.
Oh wait, are you talking about the steering wheel to the piece?
Yeah.
Okay, wait. I'll do it real quick.
Oh, so you did the 2x1 first, and then you did the other one off.
Yeah.
Okay, that makes sense. Okay, thank you. How do you delete a constraint?
To delete a constraint, you can find it in your timeline and then delete it. Yeah.
How can I make this go closer? So like I constrained like the center point of that to center point of like this
Okay.
circle.
Yeah, you can change like the offsets, like to the X and so yeah, you can find it. It's fine.
I would just take everything. I hate distraction. I would make them. Making that inner wheel, make the wheel.
But yeah, if you wanted to buy bulk candy, you can buy it at McMaster. It's pretty
It's only industrial. What could you possibly wrong with it? There's a search feature. If you want to get really straight, you could. So like every sound line, it's all the instructions. I will say, like, it's effectively cheaper than like those. So, you know, I used to. Otherwise, you gotta pay $400 a year. There's free. CAD is like unattainable.
You can buy hot chocolate.
I have a very dark thought that I don't want to like add to the recording, so I won't.
No, you can buy speed limits.
Fire.
Just imagine.
Go for big one, but
It is audio. Yeah, you can buy road signs. Like enough for it to be worth it.
$32? That ain't bad at all. Holy crap.
No, just imagine. It's in like a residential.
School zone. Put it over to school
No,
zone.
that's what I'm saying.
I download this model off the internet. Bruh. Does this count like as
Please do not download an assembly and then just submit that as your part. Like, I won't be able to know, but like, it's a very honor system. So if you really don't,
I think I'm more like 25.
I see what you're doing there. I cannot condone that, but yeah, if you want to stop something, like low key, I would get that for like a.
I spent like 2, 3 hours of my like one day working on it.
Yeah.
Like make like a special size
Yeah.
that's supposedly really fun. I could not find that. We need to be able to see the skill, the skill. Yeah, it's important. We can't see if they have the timeline.
Oh, true, true. We will know.
I've been screenshotting like this.
Yeah, that's fine. That's true. I forgot. Single use plastic. I feel like that's something.
That's micro USB. That's not USB-C. That's micro USB.
Do you remember the back in the days where they made USB? The more like square one. I don't know. I actually never had a.
Oh, it's a magnet. That,
Oh, wait, that's kind of nice.
I still have like a power bank. Like a random micro USB.
My speaker charges. It's really old. It like when the battery is low, the audio starts peaking and it's really fast. It was just there.
There's gotta be a charger, right? For chance? It's an Ethernet converter.
I don't know. Oh, wait, that's USB.
For USB-C cable.
I guess if my laptop was dead.
That's so sad. Hello.
If you're finished, then yeah, that's fine. I cannot applaud what you did because I know what you did.
No, I
As your teacher, I cannot applaud you for making two suspicious towers next to each other.
it's not. Oh my god, I didn't realize that. I didn't realize that. No, it's not my day. It's not even a place. You know, it's like
Oh, you would never.
So let's use 25 different diamond bricks.
It can just be like 25.
Okay, that's what I was asking, because that's not 21, that guy would be 25 the same.
I've had people say 25 on the same
That gets full credit.
thing. I can't condone it.
I figure I can spend more time working on my final.
Sure, yeah, if I want to. I'm not gonna stop.
I'm making a hand. Because I have a bunch of Arduino motors and I want to make a hand, so.
No, you have to drag.
Typically, the finals are on.
No. Yeah,
Yeah.
Because you print them, right? If I don't care if you print it, can I do that for the finals?
Yeah, but
Because I'm gonna print it regardless.
oh, if we have your own printer.
They don't let them bring us into the dorms.
Yeah.
It's banned from our dorm.
You got it. Not the freshman, I had 3 in my bed.
Alright, I need the Brian.
I wonder if it's a new thing, because they when they
They
put
keep
it in
the
the.
deal.
I thought I'd get in trouble because 3D printers are an exposed heat. But I think there's a 3D printer for the sun. It was fun while it lasted. I probably like took a couple of years off my life reading in all that PPT, but it's fine.
It's good for you.
It's worth it.
I've had mine in my room for like 5 years.
I started printing like carbon copy stuff.
I'm gonna go to Earhart to get in.
They don't take time.
Oh, yeah. That was Can I have like switch on here? Oh. Yeah, there's a hamburger. Oh, just like, I accidentally selected the wrong. Oh my gosh, this is a joke, because I don't know if I can. It does. Oh, but you're nice to wear. No, I can't. I just can't. Why not? You're all like, you're all. Game like 10. Game like 5. I know, I'm not even trying to know. Oh, they get the 5 latest spot. It's not. So like, you know, this. I'm not good enough to, I'm not good enough in the future to teach it. How many weeks in between? Oh, yeah. I bury it. Apparently, it's all like in my section, like last fall, we buried it. Just bury it. Depending on your professor, you either have or so either had a thesis or So random person got no chance. We got to take them out. Probably tell Ryan, that's okay.
Yeah, I'll set some links up.
Oh, okay.
But like, if you want to. Yeah, I'll set some links up. Why? We ripped the doors off by pushing them until they fell off.
Why are you destroying this car?
Because it's already scrapped. Yeah. So we're trying to save like the glass and stuff. Yeah, exactly.
Push it one spot forward for the new car. Build, I know. Unfortunately,